Hi, I'm Anastasia. I will tell you today about our position paper, which is the modular imperative, as you just heard. So this is a work with our team, Fernanda Graciolli at Midspiral, and also my wonderful advisor, Amin at Harvard University. Love her. So first, I just want to I want to convince you a little bit about why we care about LLMs generating more maintainable code. And really, it's because, well, as the latest survey says, software developers are really beginning to use AI tools in their software development workflows. So over 80% of software developers are already using these tools or are planning to use them soon. And actually, this number keeps increasing over time, and over 50% of these developers are actually currently using these tools. So really, the use of AI tools to generate code is becoming very ubiquitous. Something that's also interesting in this survey is that actually the positive sentiment for the use of AI tools is going down. It actually dropped by 10 percentage points from last year to this year, which I think is really cool. It's just an interesting finding. And there is some evidence that this kind of growing dissatisfaction with AI tools that help us generate code is because of the outputs that they're generating. So here we have some common frustrations for software developers using AI tools, and the top one is that the code is not quite right. It's almost right, but not completely. And also, debugging is difficult. So that's the second top frustration. And then more colloquially, we've probably heard from all our friends and ourselves that when we use AI to construct code, is that it can be very verbose and can be badly organized. So really what we're learning from this is that even though these tools can help us generate functional code, it may not always be like production-ready code. It may not be principled. It may not be following the best programming practices. And I think we deserve tools that give us code that follows best programming practices. And so we can focus on a lot of different principles in the best programming practices, but we have decided to focus on modularity. Why modularity? Every time I bring up modularity, somebody always wants to fight me about it. So if you want to, that's totally fine. I'm very ready for it. But I will try to convince you with this slide. Basically, in particular for maintainability of code, modularity helps us take big systems and break them down into like reasonable chunks that are self-contained and that interact with one another. Also, modularity is well known to be kind of an important thing. Many programming languages already support these paradigms. So really, if we're generating a lot of code in a lot of different languages, many languages and applications could benefit from more modular code being generated. We have these paradigms, why not use them? Then also, of course, over time, there's benefits for maintenance using modularity. So for example, different components can be built in parallel by developers. You don't have to understand the whole code base to make targeted edits. And of course, aiding in debugging, which is one of those common frustrations that we saw in the previous slide from the survey. You can test the components one by one, and then you can also test them after integration. So this is all well known. And this is why we think that LLMs could benefit from generating more modular code, which is our position. Okay, so what did we do? We wanted to run some experiments using Cursor and Claude Sonnet 4. We wanted to see if LLMs were, well, this model was inclined to generate modular code that follows modularity principles just off the bat without any guidance. You don't have to read all that. I will tell you the important bit. So basically, we wanted to see what if we didn't have any guidance to generate modular code? Will the model do it by itself? Did not really do it by itself, falls short, lots of different aspects where it falls short. I have listed them here, but I will also tell you for comparison's sake, we also ran these same experiments with some modular guidance. So we used what is called rubric, a DSL for kind of creating a modularity contract between the prompt and the AI output, and that did better. So I will tell you more about that on the next slide. But for now, what happened when we ran these experiments without rubric is that when we generated code from scratch, it just defaulted to being monolithic if we didn't ask for modularity. When we tried porting HTML, CSS, JavaScript to React, a lot of this modularity that was already existing in the code was amplified, introduced a lot more complexity and bugs. You might have seen this before in your own projects. Even when the changes that we requested could have been single file, like all of the files were changed, sweeping edits really, totally unnecessary. Some signatures got breaking changes performed to them, so like adding a new input to an interface that you didn't have there before is breaking to the rest of the code. And my favorite one is that the main function was consistently turned into a test showcase, showcasing the new features like, here, now you have filtering. Oh my God, this is amazing, look at me. But you don't want that in a production-ready code base. You want your main to stay the way that it was. So yeah, we thought that was really interesting. Without guidance, there's kind of not a lot of modularity happening. Then, so what we did is we added a rubric specification into the directory. And so the specification that I'm talking about is the specification of the language rubric. And then it instructed Cursor to create these specs for each module. And there's also a link to this. You should check it out. This language is available online. So basically what it did is generated these little contracts that say, here's kind of what the structure already is. And here are some checks that we're going to perform to validate that the changes we're making are actually respecting the principle of modularity. And so when we added rubric and the generated specifications, we were able to generate more modular code from scratch. And any changes that could have been done in a single file were actually done in a single file. They did not automatically modify all the files. There were no breaking changes to signatures. This is something that we validate for. And then of course, when we wanted to introduce a new feature in a separate module, which does not always happen when you ask an LLM to do it by itself, it might just add it on to an existing module as kind of a side thought. But it actually, the model managed to do it in a new module when we used rubric. And so something interesting I want to point out is that rubric was especially effective for targeted edits. So you might think about this for the future when I have this on the next slide. But creating modular code from scratch is a more difficult problem, right? Like you have to figure out the optimal breakdown, might change over time. So it was really extremely useful when we were trying to make edits to an existing code base with a modular structure. When we created code from scratch that we wanted to be modular, sometimes it could still be a little bit verbose, but that's just a fair warning that I want to tell you about. Okay, so what do we think we observed in these examples is that the model treated modularity as a pattern that it tried to replicate, not actually an underlying guiding principle for code generation. So why do we think this? Well, the LLM tried to give us code that looked modular, but actually there were hidden dependencies, encapsulation was broken. So really all of these things that make modularity a guiding principle were not there. Okay, we think that's a problem. So moving forward, we want to just tell you a couple of different approaches that we can use to perhaps encode modularity as a guiding principle for LLM code generation. And I feel very encouraged that I've heard some of these things said before today, which I love because that tells me that we're all thinking about this. And of course, everything starts with training. We're currently training for correctness, but it would be really cool if we could also reward restraint, so like shorter solutions or solutions that don't alter multiple files if that's not necessary, reward decomposition of tasks into smaller tasks, things like that, respect for existing modular boundaries. That's a more intrinsic way to do it, but there are some also really cool extrinsic ways to do it. So you've seen some talks before here today that kind of use these ways. Is that LLMs seem to do very well with concrete metrics and really specific rules. So we could use those things as a proxy for modular reasoning and then, validate that at runtime and maybe even have it iterate on these constraints and kind of see when we get to a satisfying modular solution before we ever give this to the user. We don't have to see all the stuff that happens in the middle. And the DSL like rubric does that. So we saw that was helpful in our examples. And then finally, another idea is we could kind of include an internal representation of modularity as a tangible object that the LLM can work with. So like give it sort of a modularity internal representation, or like we call it scaffolding, so that it can use that for its decision making when it's making edits or creating new modules or anything. So this can look as like a dependency graph, could look like as a control flow graph, anything, any sort of useful representation that could be helpful here. Even just like the structure of the repository is helpful, and like Cursor seems to pay attention to that. Yeah, and then we could also go one step further and use things like static analysis to show that things are satisfied as we want them to be. However, something that I want to say, there is of course always caveats. Modularity is a very nebulous concept. There is a lot going into it, and you already might have beef with this. But yes, I'm putting the beef on the board, which is basically, of course, the optimal breakdown varies, and we can't figure out what is the best way to represent a program in a more modular fashion. And then also over time that might change as well. So this really needs to be a conversation between the LLM and the programmer, and like whatever ways we're using to encode modularity as a guiding principle. This needs to continuously happen. It's not just the one-shot solution. Then also benchmarking was also brought up earlier today. Very hard to benchmark modularity. You try it. I really want to see everybody try this. Like, try to figure out a benchmark for modularity, because, well, first of all, it needs to represent real software with components and dependencies, and there's also no single metric for modularity, so you can use things like number of dependencies or cohesion or whatever, but you kind of have to pick something to make a benchmark. And then also another thing is that benchmarks are static. So when we're talking about benefits of modularity, we're thinking about things like multi-year iterative development, right? Over time, we are, we're concerned with this code being maintainable over a very long time. And benchmarks are static, so they don't really represent that. So that's a difficulty here. Okay, so just very quickly want to summarize what I've told you today. We have run experiments and showed that LLM-generated code treats modularity as a pattern to mimic and not really as an underlying guiding principle. We want that to be the case. We wanted to treat it as a guiding principle. We deserve better code generated by LLMs. So we have some intrinsic ways like modularity training, some extrinsic ways like metrics and structured scaffolding that we suggest to improve this. But what I really want to say is that we're just starting to think about this. This is a really, I think, important direction to consider. So what I really want to do is to leave you with some questions, right? Like, continue thinking about this in the shower. We have this human understanding of modularity, right? But that's human. Is it really even useful to LLMs, right? Do they care about modularity? Does it help them make better code? And also, okay, fine, maybe it does, but what if the AI modularity metrics are completely different from what we humans would consider? Can we even extract them? Can we even interpret them, right? This could all be very nebulous again. Also, I've mentioned decomposition a couple times. The granularity of decomposition is usually something that the user decides, but does the user want to have control over this, or is this a burden? And we want to come up with some kind of better solution to figure out what is a good modular breakdown of things. Also, we've been talking about modularity as a proxy for maintainability, but are there maybe other useful proxies, and maybe some that are even easier to measure? So yeah, I would love to hear your thoughts, and thank you for listening.
I think we have a bit of time for one quick question.
Thank you so much for your question. This is more of a opinion question for you.
Love that.
So before I begin, so I agree that modularity is important.
Don't be afraid of me, it's fine.
My question is, so on a real setting, there are many different design decisions that people need to do on their system, on their software. How do you think that, on your opinion, on your expertise working with these specific design concept, design decision. How do you think that these different decisions and different criteria that developers often have for their system interact with each other when we try to ask the model to make code generation, to make code transpiration, because if for modularity it's already somewhat a challenging task when we try to introduce many different design concepts and try to improve our software based on them. How do you see the models interacting with all of these?
Yeah, this is a wonderful question. So I'm a little bit of the wrong person to ask because I'm a diehard modularity guy, so I will tell you it's the most important metric ever. But really what the truth is that composability of software components is an important feature, right? And it's kind of a basis of what we do as developers, and iterative development is based on this idea of adding new features over time. So I really think that in the very basic capacity, LLMs should be able to respect that at least. Currently, that does not seem to be the case, and I really look forward for the time that they do.
Okay, thank you. Can I ask just one? Okay.
We can talk later.
I'll talk to you later.